Hello, we are discussing about GATE 2010 ECE paper, and this question is related to analog circuits. Look at the circuit shown. In the silicon BJT circuit shown below, assume that emitter area of Q1 is half that of transistor Q2. The value of current I0 is approximately equal to, what is the value of I0? If emitter area of Q2 is double the emitter area of Q1. Okay. So what is the value of I0 we are going to calculate. And if you look at this circuit is going to be called as current mirror circuit. It is current mirror circuit. And let us assume the current flowing through this one is going to be I reference. Okay. I reference is the current which is flowing through the base, which is flowing through this Q1 transistor. The current, it is going to be dividing into this side as well as this side. Okay. And if you are going with both the transistors are given with same voltage, same base to emitter voltage, that is nothing but VBE. VBE is going to be same for both the transistors, and both the transistors are identical except for the emitter areas. Only emitter area is going to be differed as it is given. That implies nothing but all other parameters are going to be exactly same for Q1 and Q2. That can be assumed. So Q1 and Q2 are identical transistors with only difference in the emitter area. Emitter area of Q1 is half that of emitter area of Q2. That is, emitter area of Q2 is double than the emitter area of Q1. Then what will be the value of I0? That we have to express. First we will calculate I reference. Okay. I reference can be calculated by going through the KVL from this ground node towards in this way. Okay. Towards -10. So apply KVL through this path. This is collector and base are going to be connected together. By that time a BJT simply act as a diode. Okay, whenever collector and base are going to be shorted together, at that time the diode is the transistor act as diode. And now the voltage across this one and this one is going to be same, which is nothing but VBE. So now if you apply a KVL, KVL says that one, this is minus I reference into R, okay, minus VBE plus minus of -10 is equal to 0. Minus I reference of 9.3 kilo ohms minus VBE of silicon is 0.7 volts and plus 10 is equal to 0. 10.7, 10 minus 0.7 is 9.3, so that you can write it as I reference is equal to 9.3 divided by 9.3K, 9.3K, which implies nothing but 1 milliampere. Okay. So this is a current mirror circuit and both the transistors are identical. If they are identical with emitter areas also, by that time, okay, I reference is nothing but I0. I0 will be same as I reference if both the transistors are identical, even in case of emitter area also. But here it is given as emitter area is going to be different, so we cannot say I0 is equal to I reference. So by that time you can express I reference is equal to, I reference is nothing but current flowing through the diode connected transistor Q1, where you can express this one as IS1, that is reverse saturation current of Q1, into e power VBE divided by VT. You can write like this. I reference is equal to IS1 times of e power VBE by VT, whereas I0 is nothing but current flowing through Q2 transistor, that is collector current, okay, of Q2 transistor, which is approximately equal to emitter current of Q2 transistor. Emitter current is nothing but current flowing through emitter base junction, which you can write it as emitter base junction is going to be looking like a PN junction, that is diode only, so that you can write it as IS2 is the reverse saturation current flowing through Q2 into e power voltage across emitter base junction is again it is VBE divided by VT. So I naught can be written as I naught is nothing but collector current of Q2. Collector current of Q2 is approximately equal to emitter current of Q2, and emitter current is nothing but current flowing through the emitter base junction of Q2. So which is nothing but emitter base junction of Q2 is nothing but a PN junction which can act as diode. So we are replacing the IA2 with diode current equation. Okay, it is approximately equal to is2 into e power VBE by VT. Strictly speaking, it is e power VBE by VT minus 1 according to diode equation, but VBE is positive, so that my minus 1 can be neglected. E power positive is very large compared to minus 1, you can neglect that one. Okay, so now if you observe the reverse saturation current general equation of reverse saturation current is, okay, it has given as A times of Q into, okay, dP by LP into Pn naught plus dN divided by Ln into Np naught into e power V by Vt minus 1. This is what the general equation for the reverse saturation current. So that implies nothing but reverse saturation current is directly proportional to area. Area implies nothing but area of the junction. That is nothing but area of emitter base junction. Base area is going to be very small, so that we say that one is directly proportional to area of emitter itself. So is is proportional to area of emitter. Now you can write like this. Okay, so if area of emitter is large, at that time reverse saturation current is also large. So I naught is equal to is2 into e power VBE divided by VT, what you have written. That implies nothing but is2 and is1. You can write it as emitter area of Q2 is double than the emitter area of Q1. So you can write it as 2 times of is1, because it is is1 is reverse saturation current of Q1, is2 is reverse saturation current of Q2. Q2 emitter area is double, so that you can write it as 2 times of is1 into e power VBE divided by VT. And if you write this one, is1 into e power VBE by VT is nothing but I reference. So 2 times of I reference. So that implies nothing but I naught is equal to 2 times of reference implies nothing but reference current is 1 milliampere. So the current flowing through this one is nothing but 2 milliampere. So current flowing through Q2 transistor is 2 milliamperes. So this is the current flowing through Q2. This is 2 milliamperes now. So the right option for this question is B. Thank you.